Hello everyone, this is Professor Suraj Tomar, CSIP department in SIID in South of Institution. Now, here is the topic of sorting. What type of sorting we can use and apply, and how to be resolved to the sorted part or unsorted part and converted into the unsorted to sorted. As per RGPV syllabus forces. Now, here is the sorting algorithm are applied. A sorting algorithm is used to rearrange a given array or list of elements according to a comparison operator on the elements. The comparison operator is used to decide the new order of elements in the respective data structure. Sorting. Sorting, there are a sorted element in the given array, unsorted element converted into the sorted element. It depends on the arranging in a ascending orders. In there are we having the elements of arranging the array size is 1, 170, second 45, 75, 90, 802, 24, 2, 66. There are 9 element of unsorted. We can sorting apply. We can uh, we can see that the sorted element are arranged in this order: 2, 24, 45, 66, 75, 90, 170, and 802. Now, we can see that the 802 is element in unsorted, arranged in array size, fifth element. Now we can apply the sorting in selection sort. We have using the rearranging in ascending order. There is an ninth position. We can sort it is applied. Now, the selection start by finding the smallest entry. First of all, we are using the smallest number and we compare that the highest number in each section and each size of array element present in the given array. Now, swapping the element in the entry with the first entry. Now we can see that here is the sixth element and there is a 0 to 10 number of elements are presenting in the graphically order. Now the selection sorted is applied. The swapping the smallest entry with the first entry. We can see that depicted in the graph in one element below to 10, and the red one is shown in the unsorted of selection sort. Now the part of the array is now sorted. There are yellow part, first element and second element. We can see that yellow portion are sorted array of the element, and the unsorted side is we can see in the graphically order. Now part of the arrow is now sorted. Now we can see that unsorted and sorted part. Now the compare with the smallest unsorted array into the size of an array given the next element. Now the process is continued and the smallest and compare between the fourth element, fifth element, sixth element, seventh element. Now we can here we can see that the process keeps adding one more number to the sorted side. The sorted side has the smallest number arranged from smallest to large. Already we can learn that. 1, 2, 5, 3, 4, 5, 3, 4. And now we compare it unsorted. Sorted and unsorted. We can compare that the smallest one. Now we can sort it process is going on. Now we can stop when the unsorted side has just one number, since that number must be the large number. Now here we can see that the selection sort, the array is now sorted in the yellow part. We repeatedly selected the smallest element and sorry, move this element to the front of the unsorted side. Now, the sorted program R follows these functions, and the integer ith and jth element minimum index one by one move boundary of unsorted subarray. For I equals to 0 and I is less than n minus 1, then it implies that the I incremented plus plus I plus plus. Now find the minimum element in unsorted array. Minimum index is I. For j equals to I plus 1 incremented 1, then j compare that the less than equals to not equals to n j plus plus. If array j and less than array minimum in order of index and minimum order of index jth element are present in the sorted given array. Now, swapping the found minimum element with the first element if minimum order of index, swapping array minimum index and ith element. Function to print an array, void print array, integer array, and integer size. Integer I for I equals to I is less than size, then incremented I plus plus. Then the process is continuous going on, counted as arrange ith and counted that till the end. Driver program, integer main, integer add, and array size. Given array size are present in, we can see that 64, 24, 12, 22, 11 element in integer and size of array. Now is size of array is 0. Now the function called selection sort. Now there is an array and n number count less than sorted array. Then print ln next line print array return 0. Now the selection sort and the output comes goes to 11, 12, 22, 25. Here we can see that there are given an element 64, 25, 12, and 22, 11. Now we can see that here is the output. Now we sort it to the smallest one to greater one. The smallest to arranging the ascending order like 11, 12, uh, 22, 25, 64. Here we can see the output 11, 12, 22, 25, and 64. Complexity analysis of selection sort. The time complexity of selection sort is big O and square. Is there are two nested loops we can use. One loop is selected an element of array one by one, big O n. And another loop is compared to the element with the every other another array element On. Therefore, overall complexity On into On is equals to On is square. Thank you.